Okay, so in short, maintaining earlier versions of a model can be key for going back and discovering where dynamics came in. Certain dynamics appeared, certain interesting patterns you may not have noticed earlier, where those first came in. You can find where errors crept into the model, etc. It can be very, very valuable. Okay, so be sure, if possible, using a version control software. Otherwise, using a software for just by saving manually to versions. Oh, I'm uploading the wrong thing there. What am I doing? That's a horrible thing. Okay. Be sure to save versions of your models one way or the other. Okay, so here we go. Version 2, uploaded. Okay, done. Great. Excellent, ladies and gentlemen. So let's now proceed to step 3 with this. Okay, so
the transition between shedding and recovered, I know we pulled it from the parameter in main. Does that timeout period, I have mine in hours, was it canceled because we pull it from the parameter, which was in days?
Okay, so what my recollection had been from some experimentation, and Kurt seemed to confirm, is that you actually need this to be consistent with where it's defined. I mean, it's so unfortunate because they have the requisite ability to convert. I mean, they could readily do that, but the way it's been implemented by any logic, you know, you might say days here, for example, that this is days, but currently, and maybe they'll fix this, but currently, if you go and you actually use it, and you were to say here, hours, then it would just blithely take that numeric value and treat it as hours. Is that your impression, Kurt?
Yeah.
So it doesn't automatically rescale it, which is unfortunate. That had been my observation before Scott Hebert's observation, and now Kurt's.
I mean, I think ideally what they should do is remove the unit function from there.
Exactly.
And then sort of
use the units in.
the time.
Yeah.
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 Or like if you specify a timeout using a time variable.
Yeah. Then it gets rid of the units here.
Yeah.
Yeah. Yeah. Exactly. They don't need these units. It just adds layers confusion.
Yeah.
And it can fool you into thinking, oh, it does convert in some way or what have you. Okay. Okay. So, ladies and gentlemen, I would like you to go and okay. Yeah. This is right. Okay. So what I'd like to do is to go to main, and we're going to add a statistic to count the number of people that are infected. Now, it's been probably 2 days since we did this, since we used statistics, particularly to count the number of people, say, infected or in a certain state. And I'd like to jog your memory about how this is done. Does anyone remember, where would we go to add a statistic about people?
People, then you have to start collecting statistics. Yeah.
So to which thing?
So to person.
Okay. Actually, person, you won't find the statistics in here because it's statistics on a population. So it's a good question. I mean, in some ways it would seem sensible that it be in person because statistics about people that would carry from multiple population to another. But we actually do it on the population. Okay. So if you go to the population in Maine, you go down Maine, there's this area of statistics. Do you see that? Yeah? So let's add in a prevalent case count for people. We'll ask if they're in the shedding state, okay? This is the underlying situation. Ladies and gentlemen, what sort of statistic will it be? You may remember this from the first day. What sort of statistic will this be? An average, a sum, a count? Count, okay. Good. So it's going to count the number that match some criteria, that match some eligibility criteria, some condition. What condition will this be? Well, remember, it's going to go through and name, I even did a little illustration of this the first day. It's going to go through and give each person the name item and going to run this eligibility test on them. So what's the test going to be? Item is person. It's going to be each successive person, the name for the person being considered for eligibility. What's it going to be? What's the eligibility criteria going to be here? Item dot in state, and we have to actually say person dot shedding, because there may be deer shedding. Back in the back row there's a wheel of vomit. So shedding occurs for many types of animals in your neck of the woods. Prevalent case count the number that are in a certain state. And this is the state, person dot shedding. Are we okay with that?
So what I've done before, is I've gone to person and then gone in the action in the person in each stage susceptible, for example, then add plus.
Yes, you can do that.
So it's the same thing.
Yeah, we'll actually be exploring that more within the next day or so. Okay, so it'll probably be today and maybe tomorrow morning. Okay, yeah, and because there's some statistics like incident case counts that you can't get through statistics on the population. Statistics on the population will give you a cross-sectional summary statistics of the population. They will not give you incident case counts, for example, and some more involved statistics. They're not going to give you. It's for very basic stuff. Okay. Okay. Now suppose we wanted to give a fraction of the population. So a prevalence statistic. It's not a rate. We shouldn't call it a rate. It's not a rate over time. But we'll call it fractional prevalence. Right? How would you do that? There's actually several ways to do this, but can anyone think of one way using average? Okay, I'm going to propose we use average. Average over the population of what? Well, if they are shedding, we'll give them a value of 1.0, otherwise a value of 0. And we take an average over that, over the people. Let's suppose half had value 1, half had value 0. Then the average over that population would be 0.5, which is the prevalence. Suppose that 3/4 of the population were not shedding, they would have value 0. 1/4 were shedding, they would have value 1. You take the average over that, you get 0.25, which is the fractional prevalence. Do you see that? Yeah. So, does anyone remember what this meant? This harks back to the first day as well. And you may have blotted the memory out. But what does it mean? Does anyone remember?
If statement.
It's an if statement. We actually saw it in the other room that first morning. That's an if statement. If this thing is true, then 1, otherwise 0. Do you remember that? Okay, so that's for fractional prevalence, this statement. We could simply sum it up over, average it, and the condition is we just leave it blank. Everyone's going to be counted in the population. We're not restricting this calculation to a certain subset of the population. Are we okay with this? Okay, now ladies and gentlemen, let's create a graph in main of the fractional prevalence over time. Where do I go? Whence does that graph come?
Palette?
Indeed, palette. And where in palette?
Analysis.
Analysis, indeed. And what sort of plot would suit our purposes?
Just plot.
A time plot, ladies and gentlemen, a time plot. Okay, a time plot here. Here we go. Okay, so ladies and gentlemen, a time plot, and this is going to be called prevalence. Prevalence of shedding plot. Plot the prevalence of shedding, okay? And then what do I do to plot out the item, to plot out that statistic? How do I do that? Anyone?
Add data?
Yeah, add data, that's right. Okay, good. Add data in, okay? And do I do a value or a data set? Value indeed. And what is the value? Can anyone riddle me that? We saw it the first, probably second day maybe. How would I get the value? Who computes the value? Wherein does the value live?
Population?
It's in population. So this dot population dot, and we'll see, the first thing in mind that's proposed is fractional prevalence. Who created that fractional prevalence? You did. Not 5 minutes earlier. Okay? So just created that time plot, but we have 2 more things to do. Do you remember when I told you when you create a time plot, there's a couple things you want to reflexively check? What's one of them?
The recurrence time.
Yeah, you want to check the recurrence time. This says update date automatically. That's fine here. And then how long is the time window? 100 hours is awful short, ladies and gentlemen. 100 hours is awful short. So maybe we'll make it, over 1 month or something like that. 1 month. And we'll display up to sure, 10,000 samples. How often do we need to display it? Well, every hour is a bit much for the fractional prevalence. Maybe once a day. So just mind your units here. And one way you can get a really slow model, pathologically slow model, is if these things are very small, like seconds. And one way that can very easily happen for a beginner is if you add a model, forget to change the time units, the default are seconds. You go add a graph, and the update time is once every 1 second. And then you say, oh, I forgot to change the time unit of the model, I'll change it to year. But you've forgotten the fact the graph is still at time units of once every second updating. Now you're trying to simulate phenomena on the scale of a year, and this graph is trying to update every second. And it will be, I'm not sure how a vet would view this, but I think the German expression for it is it'll be pig dog slow. Be very, very slow. Okay? Schweinhund or something. Okay. Okay. So, ladies and gentlemen, now we have this plot, and it's plotting based on this new statistic that we defined in the population. Okay. Okay. So now we should be able to run this thing, and we should be able to see a graph of fractional prevalence here, which is going to start small, but then shoot up over time. Okay, ladies and gentlemen, I did that fairly quickly. What did I do? Let's rehearse that. I went to Maine. I went to the agents and the population of agents. Ladies and gentlemen, population of agents here. And I defined a statistic, two statistics, prevalent case count, where we tested out this idea of counting the number that fall in a certain state, and then fractional prevalence, where I averaged over this expression. And I argued that averaging over this expression is mathematically identical to computing the fractional prevalence. Okay? And then I went up and added a time plot. In that time plot, I did a couple things. The first, well, I added a data value, called it fractional prevalence of setting, and I computed it by calling off to the population and asking for its fractional prevalence. This is the statistic that we just computed, we just defined in that population, right? This is the statistic we just defined. Okay. Then I further went down and made it sure it updated only once a day, first time at 0 days. I said display up to 10,000. It's not going to use that probably, and maybe I overdid it. Maybe I should have said 1,000. And I made it a time window of 1 month, because I don't want it scrolling away after 1 day or 100 hours, which is less than 5 days. Okay? Are we okay with that? Okay. So we've added a statistic and a plot. In the next job, ladies and gentlemen, will be to add the environmental dynamics. So I'm gonna